Okay, this is something that I've created before. So a part that could be very well be manufactured in 3-axis, but obviously due to the nature of the surfaces here, it lends itself to U5-axis very nicely. So a little bit about the way we use geometry in 5-axis mode. For those of you who are familiar with the 3-axis parts, what we do in 3-axis mode is we actually, everything that you see is what we machine. In 5-axis, it's a little bit different. We don't do it that way. We actually allow you to select the surfaces that you want. And then let me talk about that. So in this particular case, look at the control geometry. I'm doing what's known as, actually, let me start out with a brand new between two curves machining. I'll show you how the programming is actually done. So I'm going to use the between two curves machining here. So the first thing you do, you define these two sets of geometry. One is called the drive surface, and then the drive curves. The drive surface in 5-axis mode, as compared to the 3-axis mode, there are two things associated with the cut pattern. In 3-axis, when you said parallel finishing, you would say basically take parallel planes along the X or the Y axis or any angle axis, and then basically slice the model, and then wherever this model is sliced is where you're cutting. You can think of it that way. But in 5-axis mode, apart from the X, Y, Z coordinates that we obtain from slicing, we also have the surface normals we use to actually position the tool along that surface normal. And then obviously there are some additional controls you can use to control the angles and the axes of the tool. To define that, you have to have a surface. So the surface basically gives us not only the coordinate points, X, Y, Z points to position the tool to, but it also gives us the tool axis vectors to use to position the tool. So I'm going to select the surface that I want to machine. So that would be one surface. I'm going to select the other surface, and then I'm going to select that surface as well. So those are, or there's one other surface down at the bottom. So I want to machine all of these surfaces. Okay, once I do that, and then the other important thing is to, in surface normal or surface machining, is you have to define the tool axes, the surface normal, and make sure that they're pointing the correct way. As you can see, the surface normals are all pointing down. So I'm just going to do flip all normals, which allow them to point upwards. And this basically defines your tool axis vectors to say I'm coming from the top to machine rather than coming from the bottom to machine. That's what it does. Okay. All right, and then I've selected these two curves as flow curves machinings. And let's talk about Gout check. Let me generate this toolpath first. So it's going to run. Okay, there's my toolpath. As you can see, let me go in and change the step over direction. Please type in your questions if you have any questions, and I might be giving you a lot of information here. So I want you to make this as interactive as possible. So I changed the step over direction, step over control amount, which basically controls the distance between two successive cuts. And as you can see, it's a really nice toolpath. But as you can see, these gray surfaces down here are being machined, which we don't want. And the reason this little boss that's sticking out is not machined is because it's not part of the control geometry. I didn't select that as the drive geometry, so it's fine. So how do we avoid these? So that's the other set of control geometry that we have in 5-axis, which we call Gout check geometry or check geometry. So basically we can tell the system that, hey, I want to machine these surfaces, but I want to avoid these surfaces. So basically check against them. So I'm going to add these surfaces as my check surface. I'm going to select them. If it's a poly surface, it's probably easier to select the Okay, let me select that. Let me, for sake of, I don't want to select that for now to keep it quick. And then we also have a gout check strategy. So we can leave out the cutting gouging points. Or we can retract along the tool axis and by a clearance and not machine those surfaces. Let me do this first. If I do that, it's still machining. As you can see, it's avoiding that gout check geometry that I selected. So that's very similar to the way it handles this boss, because I did not select it in the surface geometry to machine. But here we're actually specifying this to be avoided. And the other thing I can do is, instead of doing that, if you don't like the way it picks up over that control geometry, I can go back in there and change my gout check strategy to actually retract along the tool axis. That might give you a better tool path and a lot less vibrations in the tool. So here, basically, we're moving up above that surface and not and avoiding it completely. So those are the two types of, or three types of control geometry, if you will, that we have in 5-axis mode. A little bit different than in 3-axis. So we have the drive surface. Drive surfaces define your cut pattern, not only your cut pattern, but also your tool axis vectors by taking the surface normals from the drive surface. And then you have drive curves, which actually, depending on the way you select it, they define the cut pattern on the tool surface, on the drive surfaces that you've selected. And finally, we have the gout check surfaces, or check surfaces, that are the surfaces that you want to avoid. So these are the three types of control geometry that we have in 5-axis mode. It's a little bit different than the 3-axis mode. That's why we spent a lot of time trying to make that distinction.